Welcome to The Explainer, presented by the Foundry by Forge College. I'm your host, and today, I'm putting on my chief engineer hat. We're going to explore the schematics of automation together. So, let's dive right into our introduction to deployment scripting.
Okay, so think back to the previous lesson, the final capstone, where you built and documented that deployment strategy. You just finished detailing that massive manual checklist, right? Remember all those command line instructions? Copy-pasting file paths, manually checking your balances, sweating over the keyboard, hoping, literally praying you didn't accidentally deploy to mainnet with an empty wallet? Yeah, we've all experienced those dev disasters. Well, it is finally time to retire the notepad. No more manual copy-pasting for us.
All right, let's dive into this. Here is exactly what we're dismantling and rebuilding today. First, the anatomy of a script, then choosing your language, the magic of idempotence, safety checks, and finally, the manifest.
Starting off with Section 1, Anatomy of a Script and its 5 core components.
Look, you wouldn't build a machine without separating the engine from the fuel tank, right? So you definitely shouldn't build a script as one massive tangled block of code. A really solid, reliable deployment script separates 5 recurring gears: configuration, inputs, tasks, verification, and logging. Keeping these distinct is absolutely crucial so you can swap, test, and reuse your code without starting from scratch every single time.
Notice the hard line drawn here between configuration and inputs. Configuration captures your environment, so things like your cluster endpoints, gas preferences, and file paths to your artifacts. Inputs, on the other hand, are the things that actually change between runs, like your program binaries and keypairs. By keeping these explicitly separated, you can effortlessly switch a deployment from, say, devnet to mainnet just by flipping a single environment variable.
Then we've got the action takers. Tasks are what actually execute your plan. They upload the program, set authorities, and run the transactions. But tasks are kind of flying blind without verification, which immediately checks the blockchain to confirm that your intended state actually happened. And finally, logging. Logging is your black box flight recorder. It literally prevents you from guessing why a deployment failed at 2 in the morning. Together, these 3 work in total harmony to produce traceable output that's just perfect for debugging and continuous integration.
Moving to Section 2, choosing your language, specifically Shell versus Node.js and Python.
So what materials are we actually using to build this script? I know developers love to passionately debate their favorite languages, but let's look at this practically for a second. Shell scripts, like Bash, they're fantastic for quick orchestration, but as your logic grows, they get brittle. Error handling becomes an absolute nightmare. On the flip side, Node.js and Python are incredibly robust. Node is particularly great for Solana, honestly, because you get the Web 3.js library right out of the box. That gives you highly readable, protocol-aware checks natively inside your script.
On to Section 3, the magic of idempotence, designing for repeated runs.
Okay, we are now introducing the most critical, yet probably the most jargon-heavy safety concept in our engineering blueprint: idempotence. It basically means designing your tasks so that running them multiple times doesn't produce harmful side effects. Think of it like a recipe where it's physically impossible to accidentally double bake a cake, or like an online shopping cart where furiously clicking the pay button doesn't actually charge your card twice. Your script needs to be smart enough to recognize what work has already been completed.
Take a look at this linear workflow to see exactly how we pull that off. We prepare, do a pre-check, execute, verify, and finalize. That pre-check phase is what we call detect and skip. It essentially asks the cluster, hey, does this program account already exist? And if the answer is yes, it skips execution entirely. It acts as your ultimate idempotency date, ensuring you don't duplicate destructive actions or, waste funds.
Section 4, Safety and verification checks. These are the script's safety valves.
We've talked about skipping redundant work, but what about stopping dangerous work before it even starts? Let's map out our safety net. Take the pre-checks component, for instance. Its whole purpose is to prevent harm. The practical check, confirming the program account absence before you upload a new binary, or checking the payer's wallet balance to guarantee you actually have enough LAMP ports for fees. Automating these checks ensures your script fails fast when preconditions are violated, which completely saves you from those classic dev disasters.
Section 5, the final deployment manifest, recording the truth.
We are almost at the finish line, which brings us to the final stage of our blueprint. A deployment manifest is a machine-readable file, usually JSON format, that meticulously records the output of a successful deployment. It locks in the program ID, the deployed block hash,
the payer pub key, and even a checksum of the deployed binary. Why go through all this trouble? Because this exact file becomes the ultimate single source of truth for any later runs and for your automated CI pipelines.
I really want you to walk away from this explainer with this one core realization. Your scripts are living documentation. They aren't just some random sequence of terminal commands you fire and forget. They actually encode the intended state transitions of your application, and they house the exact checks that prove those transitions occurred successfully. It is a fully reproducible blueprint.
And that brings us to the end of our schematic. As we wrap up, I want to leave you with a bit of a provocative question. Look back at that manual checklist you made in the last capstone. What 3 actions will you choose to automate first? Think carefully about that, because those notes are going to be your input for our next lesson, where we start structuring these scripts into a modular layout. Thank you so much for joining me today. Remember to visit forge.college to learn more about this subject and to discover a wealth of other fascinating Web3-related topics. See you next time.